Hello, buonasera. Good afternoon, everybody. My name is Tony Donofrio. I'm with Handel Architects. We are an architectural firm from New York City. I'm very happy to be here in Cersai, beautiful Bologna, beautiful Italy. Thank you to Angelo and the Cersai group that invited me and had me here. It's a real pleasure being here in the middle of all this beautiful creative energy, all these beautiful products, and with all these talented people and designers all around. So it's really great to be able to get all this energy and for my own inspiration. So thank you. Next. So during the next during this presentation, we will try to talk to you, give you a little introduction about Handel Architects, who we are, what we do, and why we do what we do. Then we'll speak also a little bit about the role of the architect and the designer within the larger development and construction framework. And then we'll talk about sustainability, which is the focus of this presentation. The responsibilities as an architect and a designer to our community, to our society. And we'll also talk then a little bit about passive house and how we've been trying to implement that in the construction and the design of tall mixed-use buildings, which is mostly what we do. At the end, we'll have a little case study on Cornell Tech, a project that we've done with all the lessons learned, and see if we could all share a little bit of what we learned. Next. So Handel Architects, we were founded in 1994 by Gary Handel. We are over 200 employees, and we have so far in the last 28 years, we've done about 60 million square feet of projects either completed or in the process of being completed. We were founded on the premise that we wanted to make better cities. We believe that design matters, architecture matters, and we have a great opportunity to be a catalyst for change in society. So we have offices in New York, San Francisco, Boston, and Hong Kong. So basically we work across all of the time schedule, all of the time zones in the world. Our work distribution is very much started in New York City, went all through North America, then into Asia, Middle East, and lately also into South America. We have a pretty healthy list of clients. We started with a very good client that was very loyal about 28 years ago, gave us a shot, allowed us to start. And they're still our client, and they're really wonderful people, and that gave us the opportunity then to meet and get to work with some of the largest development firms and the largest hotel chains, some institutions, and some government work as well. Our work is typically well regarded. We get pretty good press, and that makes us very happy. And then the products that we make also, they rank pretty well within the industry that we practice. So we are not a boutique architectural firm. We are a full-service firm. So we do all through master planning, through programming, interior design, building design. We document our own designs and construction documents, and then we do construction administration as well. The pie chart in the bottom speaks about all the areas that we do work. We work across all the sectors in our industry, from public work. And public work is one of the most challenging and yet rewarding sectors that one could work. For instance, our work and our experience working in New York City with the World Trade Center Memorial has been one of the most challenging. It has been, emotionally charged, politically charged, but yes, yet one of the most rewarding experiences that we've had. And then either a large project like the World Trade Center Memorial, or like the Philippines, the Supreme Court building in the bottom, or the small building for the Parks Department in New York behind Kennedy Airport is a nature center. The scale may change, but our commitment to the work is very much the same. We do some institutional work. We were very fortunate to get some design partnerships with Sana on the Grace Farms Project Museum in Connecticut, as well as Herzog and Demiron, the Perez Museum, Miami Art Museum in Miami. Then we did some work of our own with the Santa Barbara Bowl, the Boston Conservatory, and then right now we're working on the Harlem Ray Theater on top, and that's in design right now. Next. We do office work, so design of workplace. So either as a standalone building or as part of mixed-use development. We have about 22 office buildings and more than 10 million square feet around the world right now. So our claim to fame has been the design of mixed-use buildings. And so that was the first building that we were commissioned to do, and it was in New York City in Lincoln Square, and it was a very successful project, and then that idea was taken into other places like Boston, San Francisco, Washington, and then eventually in other places in the world. Next. So we have about 46 buildings, and this is very interesting work because it allows you to create, vertically integrate all the different programs, all the different uses from, retail, offices, residential, condo work, office buildings, hotels, everything, in aligning all of the uses, aligning all of the requirements for mechanical, structural, and all the planning modules in a vertically integrated building, and it's quite fun. Hospitality, we do, We've been fortunate to work with some of the major brands that are recognizable. So we have about 30 hotels built to date and about more than 4,400 keys. Building a hotel is, as you know, it's not very easy. I mean, there are many nuances that you need to understand in terms of, working with the hotel operators, hotel owners, changes, understanding the day-to-day workings of the hotel. And basically trying to pull it all together. So so we started next. Our first boutique hotel was done in 2011. Is in 17th Street in New York City. Is the Dream Hotel, and then. Next, we were lucky to extend the work with other flags, such as Proper Hotel, the Salt, and the Standard as well. Next. And then during the last 15 years, we've been doing a lot of residential work. So we more than 151 multifamily high-rise or mid-rise buildings, and right now more than 50 residential units that have been completed or have been in the process of being completed. When we started our practice, the design of multifamily residential was not seen as something very great. Was seen a little bit as a dead end in the profession, and certainly not on par with designing a public building or a public institution or a museum or something. We definitely disagree then, and we continue to disagree right now, because residential design is the core of the urban fabric. And there is no higher, we don't believe that there's really a more important calling or a more noble design cause than building the places where people live, where people raise their families, and where people form their communities. And then, so we work around all the different typologies of residential and different economical brackets, from affordable housing to luxury housing, buildings for rent or for sale, and lately we've been concentrating in the design of assisted living, senior housing, and student housing as well. And then finally, we have, for the last 15 years, we've been really working very hard in sustainability and trying to be a leader in our industry, in the places we work. So we have about more than 40 buildings that have been certified either with LEED or Passive House, and about 15 million square feet of construction. And we'll get a little more into that. So that we, that's what we do, and then why we do it. So, we believe that as architects, we have the power to affect social change, and architecture has the privilege and the responsibility to really, push that agenda. Next. So. In terms of sustainability, and you could walk around this, all of these pavilions, and everybody is involved in sustainability in one way or another. But we all, designers, architects, manufacturers, product, salespeople, and scientists and governments, we all have a slightly different definition of what sustainability is. So I'm going to take it back to the basics. And speaking about the United Nations Berlin Commission definition on sustainable design, that says sustainable design is a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So in essence, it's about us and the resources that we have, but not only about that, it's about also our children and our grandchildren. So we depend on many resources that our planet has for housing or for food. We could cut a tree and we could plant another tree. We could catch a fish and there will be another fish. There will be other fish. But all this works when we are doing it at a rate that the whole system could be steady, could be maintained. So imagine if we have a bathtub that we're draining it and we're filling at the same rate. So the water is going to stay very much at a certain, constant level. We call that equilibrium. Right now and during the past decades, we've been draining the bathtub much faster than we've been filling it. And we could start seeing fisheries disappear. We could start seeing forests disappearing. We see pollution, plastics in the ocean, and we all very much aware of all the problems with climate change. And next. So it's about understanding what we're doing, but it's about understanding the full scope, understanding that when we buy a smartphone, we are affecting the life of somebody all across the planet who is mining for those materials to make that smartphone. So in business, we call this the 3 E's, which is like the three-legged stool, which is equity, economy, and environment. And next. So, and you need to understand each one of them, but more importantly, you need to understand the relationship between the three of them. For instance, if we just think about the economy and you just think about short-term profit, without thinking about the long-term effects, we're not going to have a thriving economy. At the same time, if you only think about environment and you're not aware of how people are making their livelihood, you're not going to have a thriving society. No, back one sec. But if you don't think about equity, then you're going to have only a small group of people that are going to have most of the resources, and then the rest of the people are going to have a very hard time, right? So, and that's not a successful society either. So, next. So, how do we design, and what is the role of the designer? What is the role of the architect within a circular economy? And how can we design a sustainable building? And the other question to all of you is, how can we not design a sustainable building, given what we know? So we all very much aware of, where we are in terms of greenhouse gas emissions, and we know what the point of no return is for 2042, both for countries that are developed and countries that are not developed. Next, and we know basically what we need to do is to turn the curve down, right? In some of the values. So one of the things that we're doing in New York City, for instance, is the fact that we understand that in New York, 70% of the greenhouse gas emissions come out of buildings. So designing buildings a little more efficiently goes a long way. If we don't, we're pretty much familiar with the doomsday scenario of, that we could expect. Fortunately, there are a lot of organizations in the world, at the forefront of sustainability. We work with a few of them. Everybody in the world works with their own organizations. We work with the U.S. Green Building Council, with Enterprise Green Communities, with the WELL Building Standard, and then also with the International Passive House Institute. So basically, we push sustainability ahead of the politicians. So, by the time, the politics and the building codes get to whatever it needs to be, we already move the standard. So what's happening is we keep the standard moving, and then the building codes catch up and become the norm. Next. So. So how do we do that? How do we start designing a building that is sustainable? So the first thing is really to be where do you start? So start probably asking some of the questions to your development partners, which is the owners, the contractors, and it's very important in sustainability to have a very close relationship between owners and the design team. Next. And some of the questions that we could start asking is, can this building be a driver for net zero by 2050 goals, for instance? Or can we orient the building so if it is an office building and we just have, mostly daylight in the building and most of the day and save energy, for instance? Can we create comfortable green open spaces that every user in the building has access to? Can the building breathe a little better? How can deliver better air to everyone through the building? Can we cool the mechanical systems of the building with geotechnical with geotechnical approach? And then what if we were able to recycle energy? So let's say we use the energy for heating, and then we use the energy to heat again with that energy without reusing additional energy. So by the use of a heat recovery unit, we'll speak a little bit more about that. And then another question is, what if we could really recycle all the water that we need in the building? And what if we could power all of our workstations, with sunlight? So these are some questions, next, that we could start asking early on. So, but what is Handel doing, in terms of sustainability? So we're going to talk a little bit about our mission. And so during the last more than 10 years now, we have a sustainability committee who is put together a mission and an action plan. And the action plan is very much about, hitting the, reduction of carbon emission, about water conservation, about resiliency, about specifying healthier materials. And it's also about being a thought leader. And we'll speak a little bit about each one of those. So, next. I'm sorry, could you go back 1 second? And I want to give you a little metaphor about our mission. So if you think about each one of us and each one of our actions is like the leaf on one tree. So every leaf of the tree creates the energy for the whole tree. The sum of all those leaves are the branches. And then the mission is like the roots that are beyond just below grade, and it roots the whole system. the whole system, works because of the root network, but it all depends on the action of every one of the leaves. So the action plan is, simply about communicating our values. It's about, educating our staff, educating ourselves, educating the clients, and it's about contributing to the change in the industry very much. Next. And both the carbon and water are to try to hit all the goals for 2040, 2050. Next. We have developed also a very extensive database of materials using the life cycle analysis. So from the material when it is taken out of the ground, how is manufactured, how is it delivered, how is it installed, how does it operate, and then how is it demolished, and how does it go back into the ground in some sort of a circular way. And then we working with ISO 14001 and other standards to achieve that goal. Next. And we use software like the Airtable that helps us maintain and it helps us, manage all this information, because there's a lot of information. There are a lot of claims from different manufacturers that things are sustainable, and then when you go look at them, not all of them are exactly what they say they are. So it takes a very rigorous process to go through it and analyzing and have a true sustainable specification basis. Next. And then finally, it's about being active. It's about, going out there and communicating and showing the stuff that you do, because we really care about the subject. Next. So going into a little bit into more detail on the sustainability, so if you do leads and things of the sort, one of the things that we look is about where the building is located. Do you have access to transportation? Next. Do you need to think about resiliency? So the bottom left is our master plan for the Greenpoint Landings projects in Brooklyn. That we had to deal with the areas of flooding, and how do you deal with that, and with the oceans, racing, and how do you deal with that, and then how do you deal with like green island effect? What do you do with water? Can you retain water in the site? And can you reuse it for building purposes or for irrigation? And then what type of planting should you use in order to, you have local plantings that they're not foreign to the area, that also contribute to the retaining water in the site, and they are non-invasive. Then, in terms of water conservation, we were working with all those beautiful products that all of the manufacturers make, and try to keep all of the the low flow fixtures, leakage sensors, and smart controls, just to minimize the use of water, really, because it's a great resource. But then, more importantly, is the use of energy, and the use of energy is, for instance, the use of integrated lighting controls, the use of very, very efficient mechanical systems, the use of efficient appliances, and also creating a sense of understanding of that you're using energy. So the use of sub-metering in a large building for offices, for all residents, and the use of BTU meters, it's really great so that people understand that they're not just paying the rent, but they're also using and contributing to to maintain energy as well. And so they're conscious of how much energy they use. Also try to create a more healthy interior environment by not using VOCs, so having a smoke-free environment, having access to open spaces, and then the prevention of mold as well. Next. And then one other point that we want to talk about is the passive house. And passive house is an European idea, basically. And it's a program, is a rigorous certification program that deals very much with saving energy. And it concentrates very heavily on the mechanical systems of the building, as well as having a very tight envelope, and also provides much more efficient and wonderful interior environment. We'll go a little more about a passive house. Contrary to other pass or fail systems, passive house makes you test and makes you prove it. That the thing is working really. It's not like it's not like LEED or some other thing. So it's really very strict, and they give you a certain amount of energy that you could use. So you could use only like 31.1 kBTUs per square foot per year, and basically that's all you could use if you're going to be certified. Then the heating and cooling capacities depend on the regions, and the other stuff remains the same, all the air changes and the balancing of the system. So Handel, so we have a bunch of passive house projects, and as you could see, is how do you take that little idea of the passive house, European, and then how do you put it in, and you put it vertically with a lot of it throughout the building, how you separate it. So we have 4 examples here of different uses. One of them is a student dorm, the other one is and it was the tallest in 2013. It was the tallest passive house building in the world. Then Sendero Verde is a project that is going on, it's in construction right now in Harlem in New York. It's about also 812,000 square feet of construction, and it's all very much passive house certified. And then the next one is the Winthrop Center, which is an office building. It's a 76-story office building with maybe 21 floors of it. They are all commercial offices, and the commercial office component is passive house, and the other one is the University of Toronto. Is an institutional project that is fully passive house. Next, and you can see the diagram of the 4 projects. The yellow line represents very much the area contained in the certification, and the blue areas are the ones that are not certified. So when you go to you could choose to certify some areas on the building. It doesn't have to be the full building. Next. So then why do we do passive house? So basically it boils down because you could save from 60 to 80% that the energy that the building consumes a year, and that's huge. Besides, helping when stopping the dependency on oil and helping on the greenhouse effect, etc. And then the next one is also, next slide, is because it creates a much more comfortable environment. It's a superior interior air quality, and it's a quieter environment as well. How is the process of achieving passive house? So as I said, the owner and the architects have to work very, very close, early on in the project, working with the estimator, coming up with all the options, and working with, your consultants, mechanical engineers particularly, figure out what is the appropriate systems that you need to do. Get it all priced, make sure it fits the budget, and then moving forward with the certification. We get a passive house consultant typically that helps you go through the process and get certified. And these are the example of the 3 very early decisions you need to make, and you need to understand how much it costs. So, and it's going to be the facade selection, it's going to be the window selection, and it's going to be the mechanical systems. So this is from the Cornell Tech. You could see a comparison between a multi-story residential building that is, like 30 stories and a 30-story Cornell Tech, in which you could see that we were able to reduce the consumption of the building almost 60%, 58% of the energy that a similar building would use that is not passive house. And you can see the difference right there, that in heating is 38% on the regular building to 5% in passive house. And it's because of the tighter envelope. All the other areas, lighting, etc., they all very much stay the same. And even though electricity goes out at 34%, but it's 34% of 50 as opposed to 15% of 118. So it's very much, the rest stays the same, but the tighter envelope really makes it much more efficient. But the first question the owner asks you is, well, how much is this going to cost me? How much, what is the budget for this? So we definitely have, from a cross-section of 16 projects that we've selected, we looked at a maximum of 8% of budget increase, and a 4% is the average very much in the budget. Now, a lot of that money, the payback goes back to the tenant, in a rental building. If you own the building, you consume less energy, so it goes back to the developer. So the payback depends on the structure of the ownership of the building. And if you sell the project, you increase the value of the project. So we're going to talk about a little bit more in depth about the Cornell Tech, the house at Cornell Tech, which is the first passive house tall building we've done. These are some of the fundamentals that we're going to just go very quickly over. So the first one was obviously the orientation, placing the building in the right orientation, and understanding what the requirements of each one of those those things are. For instance, the south, how much cooling, how much heating, etc. And next. So this was the diagram of the scheme, the architectural scheme that won, and we call it the wrap. It's a plane that wraps around, and we have a slit of openings, which all the terraces are located. And we look at shapes that are more compact. That tends to minimize the exposure. And then the other thing that we look at is that the low surface to volume ratio. For instance, if you take a studio apartment or a 1-bedroom or a 2-bedroom apartment, you have only one wall that you need to be concerned with. And as compared as to if you have a house in suburbia, the fact that the exposure ratio is completely different for what you need to heat and what you need to cool. So that's why we think that having a good design building in a city has the least impact on the resources. Next. These are some of the different values for the buildings in terms of insulation and U values at the different components. And this is a comparison between a standard window and the windows at Cornell Tech, which were triple glaze, obviously. And the solar heat gain coefficient is, very much the same, but in the U value and of the window as a whole and of the glass, you can see incredible reductions. That makes it very efficient. This project also was a panelized building system, which it was built in the shop. Definitely, it was much easier than to maintain a very continuous air and weather barrier and insulation barrier. Next. And as a panelized system, the weakest point is always the joints, and therefore you require a very extensive inspection program through the project in order to be able to maintain that. So the panels being delivered. Next. And then you see them installed, and you can see that green membrane, all the joints are taped, and it has to be installed to the point in which, everything is tight, and then you have to test it. So, and you have a 28-story building, you have a fan on the top, one on the bottom, and then you open all the windows within the building, and then you start blowing air in, and you measure the fact that there is no air being missed. So you're really testing not only how it's put together, in terms of the design, but you need to make sure that the final product that is constructed gets tested, and those tests go into the certification. Next. Also, when you have elements that are inside the building into a heated environment, and then it goes into an exterior environment, you can see the slit of terraces, which is where we have all the condensing units. You have the slab that goes from concrete that goes from inside to outside, and we have the separators, the isolators, of thermal isolators of rebar, for instance, at that point. Another area in which you lose a lot of energy within the building is like lintels, where you hold the brick, and so you have continuous areas of thermal bridging, and we use, paths, separators, as well as another system called it's a shelf angle. Is the I forgot the name. I forgot the name. Okay, it'll come to me. I'll tell you later. So, but again, what it is a bracket that pushes the lintel out and allows for the installation. Ferro bracket, that's what it's called, by the way. It allows for the installation to go through. So it minimizes the thermal bridge, and also the parapet areas of the buildings. They are it's all the perimeter of the building, and it's one of the areas that loses the most heat. And just by the use of AAC blocks, it allows also to have a very tight envelope, continuous insulation. But again, one of the most important things is the mechanical systems. This was a VRF system. Next. And it's very much the arrangement of the VRF system. This is a horizontal scheme, and you can see at the bottom here where the condensing units are. And you have a condenser unit that at every terrace that handles 2 floors, one on the south because it's the one that receives more cooling, and the other one, and 2 that handles the north that receives more heating. Next. And this is another example from another one. It could be a vertical system in which all the condensers are in the roof, and then you have risers that come down and go to each one of the units. Next. So you have to work with very, very efficient equipment, and you have to work very closely with your mechanical consultants to make sure you have the selection of the right and most appropriate system for your building, right? For each design. And then ventilation is incredibly important as well. So we typically exhaust all of the air of the building through the bathrooms and through the kitchens. Next. And we throw air outside that has been heated at 70 degrees Fahrenheit, let's say, and all of a sudden it's 5 degrees outside. So you bring air that is very cold inside the building. So by the use of a heat exchanger, it takes the heat out of the air before you throw it out, and it heats the cold air that comes in, and it goes back into the building. So that's part of the it's one of the one of the nicest things in mechanical systems and ventilation that we deal with. And then also the use of appliances that are very highly rated, very efficient. So in New York City we work with Energy Star, which is basically one of the standards that allows us to have the least amount of energy consumed. Next. And also the use of software. You could allow everyone to understand how much, to set the temperature that they want from their phones, and also allow them to understand how much energy they're consuming and how much, so they have the power to choose how much they could use and be conscious of, when they're overusing. Next. And these are just some examples of we did a panelized system on one, but then we tested what if it was a masonry and cavity unit, what if it is an EFIS system, what if it is a curtain wall, and what if it is a stick system. So we looked at different things. Of course, we use them in different projects. Every system is appropriate for each different project and different budget. And these are examples, with some of the different systems that we just talked about, and some of the different, values that you're able to achieve in order to achieve certification. Next. Also, we talk about compact shapes, but basically, if you cannot always do compact shapes. Sometimes you need a building that is, you need to fit all the square footage, and we are able to make it work as well. So. It's more efficient to do compact shape, but if you're not, you still could achieve certification. Next. So after 1 year of design and 2 years of construction, you've done a building, you've done a sustainable building. It doesn't belong to you anymore. Next. It belongs to the city, it belongs to the community, to the people that use it, and you may get some good press about it. You may feel very good, your ego feels fantastic. But again, why is it that you do sustainability? So we get up every morning and we have a choice. And, what am I going to, everything is a choice in life. So you have an opportunity every morning to make a better world. And I'm going to leave you with two phrases. One of them is that, we are here for impact, and we are here because of systemic change. Because anything less fails to meet the urgency of the moment. And then going back to the analogy of the leaves and the tree, again, every action that we take is like the leaf in the tree, bringing the energy to the system. And in the next phrase is that individually we are a drop, and together we are an ocean. Next. So let's act for a sustainable future. Thank you. I don't know how, how much basic or how much technical it is. I didn't want to bore the hell out of everybody. And so, but if you have any questions or anything, we could talk later. Thank you.